If you have the nth root of a, the n is called the index or the root. Then you have the radical sign, which could be square root, cube root, fourth root, or fifth root. Then the a, the part under the radical sign, is called the radicand. You can simplify a radical expression when the exponent of one factor of the radicand is a multiple of the radical's index or root. You can simplify the product of powers that have the same base, such as x squared times x to the third. That would be x to the fifth. Similarly, you can simplify the product of radicals that have the same index or root. So if you're multiplying radical expressions, if you have the nth root of a and the nth root of b, and those are real numbers, then the nth root of a times the nth root of b, the root is the same. If the root is the same, just multiply what's under the radical sign. That would be the nth root of ab. So the question is, can you simplify the product of the radical expression? Then explain. So if you have the cube root of 6 times the square root of 2, first notice the roots are different. If the roots are different, or if the index is different, you cannot multiply those. So that cannot be simplified. The roots are not the same. If you have the cube root of negative 4 times the cube root of 2, now one's positive, one's negative under the radical sign, that doesn't matter. If the roots are the same, then you can multiply those. So the cube root of negative 4 times the cube root of 2, that would be the cube root of negative 8. Then just think what number multiplied by itself 3 times makes negative 8. And that would be negative 2. So the cube root of negative 4 times the cube root of 2, that turns out to be negative 2. Need to multiply if possible and then simplify. You have the square root of 8 times the square root of 32. The roots are the same, so yes, you can multiply those. Just multiply 8 by 32, put that under the square root sign. That is the square root of 256. If you go to the calculator, type in the square root of 256, that would be 16. So the square root of 8 times the square root of 32 is 16. Next, cube root of 9 times the cube root of negative 81. The roots are the same, both cube roots, so just multiply 9 by negative 81, that is negative 729. If you go to the calculator, type in the cube root of negative 729, that turns out to be negative 9. So if you multiply negative 9 by itself 3 times, that is negative 729. Next, square root of negative 5 times the square root of 5. You have the square root of a negative number, so you want to take the square root of negative 1 out. Remember, imaginary numbers. If you take the square root of negative 1 out of that, it'd be the square root of negative 1 times the square root of 5 times the square root of 5 again. And with imaginary numbers, remember the square root of negative 1 is I. Square root of 5 times the square root of 5, that is the square root of 25. So you're looking at I times the square root of 25. Well, the square root of 25 is 5, so that would just be 5i. Cube root of 9 times the cube root of negative 24. The roots are the same, so you can multiply those. Multiply 9 by negative 24. If you're wondering why didn't we take a square root of negative 1 out, well, this is cube root. So you can go ahead and multiply those together. You have the cube root of negative 216. You go to the calculator, type in the cube root of negative 216, and that is negative 6. If the radicand of the nth root of a has a perfect nth power among its factors, you can reduce the radical. If you reduce a radical as much as possible, the radical is in simplest form, also known as simplest radical form. So we're going to be taking these radicals to simplest radical form. Looking at the cube root of 54x to the fifth. So what we want to do here is we want to break this down. We want to separate this into two radicals. We want to put all the perfect cubes together under one radical sign, everything else under the other radical sign. So think about that 54. Can you break that 54 into two numbers where one of them has a perfect cube root? So you want to list factors of 54 and see if any of those factors has a perfect cube root, and that's what we're going to split that into. Then the x to the fifth. You want to drop that exponent of 5 down to the next exponent down from 5 that is divisible by this root of 3. It's better to see an example. So you're going to break that 54 into the cube root of 27 and the cube root of 2. So the cube root of 27 and the cube root of 2, the reason why we did that is because 27 is a perfect cube. Now for the x to the fifth, we want to split that into x to the third and x squared. The reason we do that is that x to the third, that 3 is divisible by this root of 3. And that is a perfect cube. So we're putting all the perfect cubes together under one cube root sign, everything else under the other cube root sign. So again, the 54, we split that into 27 and 2 because 27 is a perfect cube. Then the x to the fifth, split that into x to the third and x squared because x to the third is a perfect cube. The reason that x to the third is a perfect cube is because the 3 is divisible by the root of 3. So the cube root of 27, that is 3. The cube root of x to the third is x. And then you have that cube root of 2x squared left over. So this simplifies to be 3x times the cube root of 2x squared. That is simplest radical form. Next, the cube root of 128, x to the 7th. So again, with that 128, you want to split that into two numbers, where one of those numbers is a perfect cube. So think of factors of 128, or maybe grab the calculator and start dividing 128 by 2, by 3, by 4, until you get another factor that is a perfect cube. Then the x to the 7th will drop that 7 down to the next exponent down from 7, or the next number down from 7 that is divisible by 3, and that's a perfect cube. So for the 128, we're going to break that into the cube root of 64 and the cube root of 2. 64 is a perfect cube. The cube root of 64 is 4. And then for the x to the 7th, we're going to break that into x to the 6th and x, because the exponent of 6 there is divisible by that root of 3. That means that is a perfect cube. So again, 64 and 2 for the 128, because 64 is a perfect cube. And then x to the 6th and x for the x, breaking that x to the 7th down, because x to the 6th is a perfect cube, because the 6th is divisible by 3. So the cube root of 64 is 4. Cube root of x to the 6th is x squared. And all you have to do is divide that exponent by the root. So 6 divided by 3 is that 2. Then you still have that cube root of 2x left over. So this simplifies to be 4x squared times the cube root of 2x. We're going to simplify the square root of 28x to the third. It's going to put all the perfect squares together under one square root sign, everything else under the other square root sign. So the square root of 28 breaks into the square root of 4 and the square root of 7, because 4 is a perfect square, and then the square root of 7 will not break down again. For the x to the third, we're just dropping that 3 down to the next exponent down from 3 that is divisible by that root of 2. It's going to break that square root of x to the third into the square root of x squared. That's a perfect square because the 2 is divisible by the root of 2. And then you have an x left over. So all the perfect squares under one square root sign, that'd be the square root of 4x squared. And what's left over under the other square root sign, that's the square root of 7x. Go back to that square root of 4x squared and simplify that. Square root of 4 is 2. And the square root of x squared, just divide the exponent by the root. 2 divided by 2 is 1. So that would be 2x to the first times the square root of 7x. So in simplest radical form, that is 2x times the square root of 7x. You have the square root of 80x to the fifth. So you want to break that 80 into two factors where one of them has a perfect square root and the other one will not break down again. It's going to break the square root of 80 into the square root of 16, and then the square root of 5 will not break down again. For the x to the fifth, we're going to drop that 5 down to the next exponent down from 5 that is divisible by that root of 2, and that would be 4. It's going to break that square root of x to the fifth into the square root of x to the fourth and the square root of x. So we have all the perfect squares together under one square root sign, all the leftovers under the other square root sign. Square root of 16x to the fourth. Square root of 16 is 4, and the square root of x to the fourth, just divide the exponent by the root, that would be x squared. And then you have that square root of 5x left over. So in simplest radical form, that is 4x squared times the square root of 5x. Next, the cube root of 54y to the 10th. So break that cube root of 54 into two factors. Factors of 54 where one of them is a perfect cube and the other one will not break down again. So the cube root of 54, that'll break into the cube root of 27, and then the cube root of 2 will not break down again. For the y to the 10th, drop that 10 down to the next exponent down from 10 that is divisible by that root of 3. There'll be y to the 9th, then you have a y left over. So all the perfect cubes under one cube root sign, everything else under the other cube root sign. Go back to that cube root of 27y to the 9th. Cube root of 27 is 3, and the cube root of y to the 9th, just divide the exponent by the root, that would be y to the 3rd. So that is 3y to the 3rd times the cube root of 2y. Cube root of negative 250x to the 6th, y to the 5th. So going to break that cube root of negative 250 into two factors where one of them is a perfect cube and the other one doesn't break down again. Now that is a negative 250, and you can use that as a perfect cube. So we're going to break that cube root of negative 250 into the cube root of negative 125 and the cube root of 2. So the cube root of negative 125, that's going to be negative 5. And for the cube root of x to the 6th, that 6 is divisible by 3, so that's already a perfect cube. For the y to the 5th, that's not a perfect cube, but you can break that into y to the 3rd and y squared. Y to the 3rd is a perfect cube, and then the y squared will not break down again. Back to that first radical, the cube root of negative 125, as said earlier, was negative 5. And the cube root of x to the 6th, just divide the exponent by the root, that is x squared. And the cube root of y to the third, again, divide the exponent by the root. That is y to the first, or just y. So it'd be negative 5x squared y times the cube root of 2y squared. And the fifth root of negative 32, x to the sixth, y to the seventh. You might want to try the fifth root of 32 on the calculator, see what happens. It's going to be 2. So the fifth root of negative 32 is actually going to be negative 2. So we're going to break that down into the fifth root of negative 32, x to the fifth, y to the fifth, times the fifth root of x, y squared. So the fifth root of the negative 32, that's going to be negative 2. Now the fifth root of x to the sixth, you can break that x to the sixth into x to the fifth and x, because that exponent of 5 is divisible by that root of 5. And then this x will not break down again. For the y, you can break that y to the seventh into y to the fifth and y squared, because that exponent of 5 is divisible by that root of 5. So we have all the perfect ones with fifth roots under one radical sign, and the other, what's left over, under the other radical sign. Fifth root of negative 32, that is negative 2. Fifth root of x to the fifth, just divide the exponent by the root. It's going to be x to the first, or just x. And the fifth root of y to the fifth, that is going to be y to the first, or just y. Then you have that fifth root of xy squared left over. So it'd be negative 2xy times the fifth root of xy squared, that is simplest radical form. Going to multiply and simplify, starting with the square root of 72x to the third y squared times the square root of 10x y to the third. You have the same root, so just multiply those together. Take 72 by 10, that is 720. Then x to the third times x, that is x to the fourth. And y squared times y to the third, that is y to the fifth. So to break this down, starting with the 720, just divide 720 by 2, by 3, by 4, by 5, until you get a pair where one's a perfect square and the other one does not break down again. So if you divide 720 by 5, that will be 144. 144 is a perfect square. So put that with the perfect squares. X to the fourth is a perfect square because that 4 is divisible by the root of 2. And then y to the fifth, that's not a perfect square, but you can break that into y to the fourth, which is a perfect square, and then you have a y left over. So go back to that first radical sign, simplify that. Square root of 144 is 12. Square root of x to the fourth, just divide the exponent by the root. That will be x squared. And the square root of y to the fourth, divide the exponent by the root. That is going to be y squared. So that simplifies to be 12x squared y squared times the square root of 5y. Next, 4 times the square root of 2x times 5 times the square root of 6xy squared. Multiply what's in front of the radical sign. The 4 and 5, multiply those together. That's 20. And then multiply what's under the radical sign. 2 times 6 is 12. X times x is x squared. And then you still have that y squared. Break down that square root of 12x squared y squared. Put all the perfect squares under one square root sign, everything else under the other square root sign. So with the 12, you can break that into the square root of 4 and the square root of 3. Then for the x squared, that's already a perfect square because that exponent of 2 is divisible by the root of 2. And y squared is a perfect square as well. So that square root of 4x squared y squared, that can simplify to be 2xy because the square root of 4 is 2. Square root of x squared is x, and the square root of y squared is y. So just multiply 20 by 2xy, that would be 40xy times the square root of 3, and that is multiplied and simplified. Next, the negative of the cube root of 2x squared y squared times 2 times the cube root of 15x to the fifth y. Multiply what's in front of the radical sign, so you have a negative sign and then a 2. So it'd be negative 2 times the cube root of what's under the radical sign would be 2 times 15 is 30. Then x squared times x to the fifth is x to the seventh. And then y squared times y is y to the third. Then break that down. Now with the cube root of 30, there's really nothing you can do with that because you can't break that into two factors where one of them is a perfect cube and the other one doesn't break down again. So that cube root of 30 automatically is going to go in the leftovers. For the x to the seventh, you can break that into the cube root of x to the sixth because that exponent of 6 is divisible by the root of 3. And for y to the third, that's already a perfect cube. So the perfect cubes here would be x to the sixth, y to the third, and what's left over is 30x. So you have negative 2 times the cube root of x to the sixth, y to the third. Well, that'd be negative 2 times x squared y. Because the cube root of x to the sixth is x squared. Divide the exponent by the root. And for the cube root of y to the third, that is y. So this simplifies to be negative 2x squared y times the cube root of 30x.